Multivariable calculus, we're finishing up lesson 14.2, very last example, very last problem here. We're trying to find out where this function is continuous. And the problem, evidently, whenever you have a piecewise function, appears to be where the break in the definition occurs, namely at the point 0, 0. So we're trying to figure out what's happening. As x, y is approaching 0, 0, of course it won't really equal having x equal 0 or let y equal 0. So really we're only having x and y get close to those values. So really we're just trying to see if this limit is x, y going to 0, 0 of 2xy over x squared plus y squared will in fact work. Well, you know, if I plug in 0, 0, I'd get 0 over 0, which is indeterminate. So we need to use our two-curve test. Here's curve 1. And for curve 1, again, this is a great start. Maybe let's do the x-axis. In other words, let's let y equal 0. And wherever we have a y now, we can actually replace it with 0 and see what exactly happens as a result. Well, you can see that our numerator would be a 0, and you know, that would divide out by the x squared. We're just going to get a 0 right there. For curve 2, once we work this out, we'll think, well, should I let the y-axis be the other curve? Well, you can see that you'd get the same thing that you did in our first curve. It's just that our variables would be switched. But tell you what, maybe this would be something to help you begin to see. If I were to let x equal y, and sometimes this just takes a little bit of thought. Or likewise, let y equal x. You could go either way with that. If you were on this path, you could get some help. This would become, like I said, instead of having an x here, we'd have a y. We'd have a 2y and a y right here. This would be y squared plus y squared. Why would I choose that? Well, I'd have the same powers down below, and actually, as you look at this, you would have something very nice happening up above also. You'd have a 2y squared. Down below, 1y squared plus 1y squared is a 2y squared, and you're not going to need to substitute anything in here. I think you can see immediately this is just going to go to a 1. But these things are different. They're not equal. And what does that tell you? It tells you that your limit does not exist. And that means that we can say, therefore, G is not continuous at that point. So, really, everywhere else, if you really think about it, your function is going to be defined. You're not going to have x and y both being equal to 0. And likewise, as you're doing that, I think you can quickly also confirm that your limit then would exist, and your limit would also, as a result, equal what your function would be. So it would be continuous everywhere else. So that's our last problem. Good luck as you're working through the problems.